Okay, so we're looking at the Chapter 2 review. This is number 3. You're specifically given this polynomial and asked to do a few things. One, to put it into standard form. Two, identify the degree, identify the leading coefficient, and then classify this guy. So let's start out with standard form. Standard form means we need to take these three terms, 1, 2, and 3 terms, and we need to order them by their specific degree. So the degree for each of these individual terms. And the individual terms, by the way, are separated by either addition or subtraction. So if we look here, this one is raised to the 7th power, this one is raised to the 2nd power, and this one is raised to the 5th power. To put it in standard form, we need to go in descending degree, which means highest degree term first. So actually, this one already has the correct first term. So the 9x to the 7th is going to be my first term. What makes this guy out of order, and the reason it's not standard form, is we have this term, which is x squared, and this term, which is x to the 5th, out of order. So this guy needs to come forward. The plus goes with it, so this becomes plus 13x to the 5th. And then my final term here, minus 6x squared. So now this is correctly in standard form. So I mentioned here that each one of these little terms, each one of these monomials in this polynomial had their own unique degree. This was x to the 7th power, x squared, and x to the 5th. As a whole polynomial, as this thing entirely, when we identify the degree, we're looking for just the exponent on the highest degree piece. So I'm going to focus right in here for the degree for the whole polynomial. It's going to come right for this term right here. It is an x to the 7th power, meaning that this polynomial is a degree 7. Okay. There's a tendency sometimes for people to want to add the 7 and the 5 and the 2, and that would only happen if it was all within a single monomial like this, 9x to the 7th, and then maybe like y to the 5th, a squared. So on this thing, the degree would actually be the 7 plus the 5 plus the 2, which would be 14. But that's because this is one single contained piece. This is a monomial. This polynomial is 3 distinct pieces separated by addition or subtraction. So the degree for the whole thing is just the degree on the highest degree piece. Okay, leading coefficient also comes from this term, this monomial here. The coefficient on that term with the highest degree is the leading coefficient. So the leading coefficient here is 9. And then classify. So this is either going to be one of 3 things, technically one of 4. It's either a binomial, which is 2 terms, a trinomial, which is 3 terms. And then you also have a monomial, which would be 1 term. And then the other option would be, I don't know why I did it out of order, 2, 3, and 1. The other thing would just be a polynomial. We don't have special names if you have 4 terms or more. This has 1, 2, 3. So what we're looking for here is a trinomial. This guy is a trinomial. So I'll just put my final answer here, trinomial. So it is now in standard form by descending degree, 7, 5, and 2. The degree for the whole polynomial is 7. The leading coefficient is 9. And I classify this guy by calling it a trinomial because there is 1, 2, 3 terms. Hope this is helpful. Message me anytime with questions.